Okay, so welcome to lecture everyone, and in this lecture we are going to understand that what are the major term or what are the major component generally we talk about when we see or when we try to understand, when we try to learn a neural network for the very first time. And believe me, these terms which I am going to discuss now, you will be able to find out these terms everywhere, every time, whenever you will go ahead with any kind of a neural network in your entire life. And these terms are very much important. I believe anyone who is trying to understand a deep learning concept, machine learning, not machine learning I would say, but yeah, a deep learning, a computer vision, NLP, generative AI. So obviously you must be aware about all of these terms in a very, very clean way, so that it is not going to give you any kind of a pain in a future. So let me share my screen, and let's start talking about a neural network. So here I'm going to write it down that neural network common term. Yeah. So as I have already shown you in my previous lecture that what is our intuition behind a neural network, and what in all component which comes into a picture. I'll just try to list down over here in the simplified manner. So in terms of any kind of a neural network, there will be a input layer. So where anyone can pass a input data, and maybe you can try to call that as a x1 and x2, right? So x1 and x2 is a input data. Now I can have a multiple input, that's completely fine. So x1, x2, x3, x5, x10. So n number of x I can have over here. Just a term, so you can try to label it as a different term, that, but yeah, this is what you will be able to find out. Now, so there will be a hidden layer you can try to find out inside any kind of a neural network. Now, what is this hidden layer, by the way? So hidden layer is nothing but it is going to help you out in terms of building a relation, basically, right? In terms of building a complex mathematical calculation, because as my mathematical calculation is going to be complex, so it will be illegible enough, or it will be powerful enough to understand a relationship between the data set. So I can try to add a multiple hidden layer, that's completely fine, inside a single hidden layer. So I can try to add as many number of neurons as I want, that is also fine, depends upon me. So how I'm going to create or architect the entire neural network. And then there will be a output layer, so where you will be able to see your y hat, or you can say you can see your prediction or classification or regression, whatever it is, right? Or generation. So you are going to pass a x data, x1, x2, x3 and xn, and then you are going to get some sort of a final response. Now in between, like I said, so there will be a hidden layer. So here there will be a hidden layer that you can try to find out. Now, so how this input and a hidden layer and output will be connected? So let's suppose this is my x1. So x1 will go here, and x1 will also go here. Means x1 will try to flow through this two hidden layer at a time. And then similarly, so x2 will go here, as well as x2 will go here. As simple as that. And then, so this is how this entire things will be connected, as you can see. So as you can see that x1 data, so whatever input that you are going to give, whatever number that you are going to pass, it is going inside a hidden neuron. And then whatever x2 that you are trying to pass, so this red mark is trying to represent that it is getting into this hidden neurons. Okay, that's completely fine. Now this is the hidden layer, and I can label this as a output layer. Output layer. Okay. Now, so what happens inside a hidden layer, by the way, and why we are even talking about a hidden layer, and what goes inside a hidden layer, what I will be able to find out at this point, at this point, at this point, and at this point. So here, a simple intuition is that whenever we are trying to create a neural network, a random weights will be initialized. For example, so here, let's suppose I'm trying to say that W1, right? W1, and this is my H1 and this is my H2, right? Hidden 1 and hidden 2 that we have. So W1 to 1 and then W1 to 2. So weight is a weight which is connecting with the x1 and h1, and weight which is connecting between x1 and h2. Now what is this weight? So this is nothing but it's a random number, by the way, right? It's a random number that we try to consider, and initially we assume that okay, so these random numbers are trying to, like, create a relationship, build a relationship between the data set, but eventually this is something that we are going to train. We are going to basically change it. We are going to basically train it. Now here, so let's suppose I have a weight 2 connected to hidden layer 1. So I can write weight 2 1, and here I have a weight 2 connected to hidden layer 2. So weight 2 2 I can try to write. So as you can see that we have a weights, right? We have a weight. Weights are going to be random, and this is something that is a trainable parameter. We try to train it. And then there will be a bias B1 will be attached to this one, and bias, let's suppose a B2, which will be attached to this one. Okay. So biased. So again, this is a trainable parameter. So we try to attach some sort of errors with respect to this one. Then there will be a output layer. So even over here, so you will be able to see a B of 0 means bias you are going to attach. And here also you will be able to find out a connection, a weights, because we have a connection over here, we have a connection over here. So if we have a connection, so obviously we'll be having a weights over here. So here you can say that weight from hidden layer 1 to output, and then weight from hidden 2 to output. So maybe I can try to name it in this particular way. That's completely fine. So this is how this entire neural network will be connected to each other. At the end of the day, what we will try to do? So at the end of the day, we will try to change a weight, and we will try to change the biases. Now, so inside a hidden layer, it's completely fine. We are trying to send this x1 and w1, x2 and maybe a w2, something like this. We are trying to send over there. But what will actually happen inside a h1? Let's try to understand that. And what will be the input inside the h1? So means at this point, what will be the input? So the input which will go inside this h1 is nothing but the combination of this and this. Yeah, combination of this and this, the two dot which I am trying to represent over here, that will go inside h1. Now combination of this and this, that will go inside h2, right? Combination of this and this, that will go inside this final output layer or output function, whatever we are going to assume. So what is something that will go? It's a very simple and straightforward. So let's suppose if I'm talking about maybe a Z, and I'm writing that as a Z1, which will go inside h1, input to the h1, right? Input to the h1. So let's suppose I'm trying to write maybe a z1 over here. So the simple like a calculation will be x1 w11, right? x1 into w11 plus I can say x2 into w, x2 into w21 plus the bias b1. So plus a bias b1. Now this will be like a going inside basically this one. So one component from here, x1 and w11, and second component from here, so x2 and w21 plus a bias. Now this combined thing z1 will go inside this h1, which is a hidden layer. Now what will go inside a h2? So let's represent that as a z2 basically. So the things which will go inside h2 is as a z hidden layer 2 basically is going to be x1 w12 plus x2 w22 plus bias, right? Plus bias over here. So it is going to follow a simple linear equation, y is equal to mx plus c kind of a philosophy, right? So where the data which will go over here is nothing but this weight, which is eventually m over here, and then the input data plus c. C means bias in this particular term. So Z1 and Z2, so it will go inside H1 and H2, and H1 and H2 is basically a hidden layer. So obviously hidden layer must be doing something, right? So must be implementing some sort of function. So in general, what hidden layer try to do is, so hidden layer helps a neural network to non-linearize the data so that it will be able to understand a relationship in a better and better way. This is what like a hidden layer does all the time, by the way, right? All the time. So, okay, so Z1 and Z2 will go inside H1, and inside this hidden layer, so we try to implement something called as activation function. So we are completely okay with the input, we are completely okay with the hidden layer, and now we are completely okay with the output. So inside hidden layer, you will be able to find out something called as activation function. So inside hidden layer, you will find activation function. Now, so what kind of a activation function we are going to find out? So there is activation function called as sigmoid, there is something called as hypertangent, there is something called as ReLU, leaky ReLU, Swiss. There are a lot of activation function that you will be able to find out, which I'm going to talk about it for sure in my upcoming lectures, step by step manner, all the activation function. But the major responsibility of this activation function is to achieve a non-linearization into a data set. So means whatever linear data that you are going to pass, so it will always helps our data set in terms of understanding a non-linear relationship. Simple as that. So here we have an activation function which will go inside this one. So let's suppose, for example, I'm just going to assume that whatever you are going to pass inside this hidden layer, right? Whatever you are going to pass inside this hidden layer. So here, let's suppose I'm going to apply a function is equals to x square, right? X square means whatever you are passing inside the hidden layer, it will become a square. As simple as that. So let's suppose if I'm going to pass a Z1 and Z2, so the output that I will receive out of this one, let's assume that, again, this is not a real activation function I'm talking about, but let's assume that here I will get Z1 square and here I will get a Z2 square. As simple as that. Yeah. So Z1 square and Z2 square, maybe I can take a cube, maybe I can take a to the power 5, maybe I can take a exponential, maybe I can take a logarithmic of it. Simple, right? As of now, I'm just trying to say that there is a one activation function I have taken. So that activation function is basically x square. So whatever you are going to pass, it will become a square of it, right? Just for the explanation purpose, I have taken that, nothing more than that. So, okay, so Z1 square and Z2 square I will be able to get. So once I will be able to get Z1 square and a Z2 square, then again same thing I will try to do. So this into this, this into this, summation of this will go where? So go into the output one. So what is the output? So what is the Z of 0 you will be able to find out? So Z1 square into W 1 0. So weight 1 0 plus Z2 square weight 1, so sorry 2 0. So weight 2 0 plus bias B0. So this is something, this Z0 you will be able to find out that which will go inside this output neuron, Now, if you will go inside the output neuron, so obviously there must be some sort of a output function, right? Output function. So which is going to produce a Y, right? So there must be some sort of a output function. So again, there are multiple output function that we can try to choose, which is similar to the activation function, I would say. So output function will help you out in terms of giving a output of the entire neural network. So let's suppose if I'm trying to do a binary class classification 1 0, let's suppose I can do maybe a multi-class classification. Let's suppose I'm doing a regression, so which is going to give me some sort of a numbers. So here there will be an output function. So inside this, so let's imagine that output function is basically a root. So whatever you are going to pass, so it is going to give you the square root of those data as a output. Okay. So Z0 you are going to pass. So what is going to be the output? So output, or you can say Y hat, Y prediction. So let's imagine that it is giving me a root of Z0. So Z0 I have passed over there, right? Z0 I have passed over there, which is a combination of these two. So it is going to give me this one. So that will become what? That will become basically a Y hat, means Y prediction. System is going to give, or neural network is trying to give me basically a Y prediction. Okay. Now, once you are going to get a Y prediction, now, so by doing or while going through this entire neural network, if I'm able to get a Y hat, now it's pretty much obvious that these weights was, or these numbers that I have taken, the biases that I have taken, which is responsible for building this relation and eventually giving me the final outcome, it was a random one, right? It was a random one. It was not the exact one. And so it will not be able to understand the real relationship between the data, right? It will not be able to understand the real relationship between the data. So to avoid it or to mitigate it, basically, right, or to make it correct, what we can do, so we can try to change these weights and biases so that my relationship will be better and better. Because how I'm getting Z0? Obviously, I'm trying to do some sort of a multiplication addition with respect to this weight and biases, right, which is eventually helping me out in terms of establishing the relationship in a layer by layer fashion, right? So what I have to do is I have to change this weight and I have to change this biases. Now, when it comes to changing a weight and biases, right, when it comes to changing a weight and biases, so obviously we can try to change a weight and biases. That's completely fine. But based on what, right? Based on what? So based on basically a loss. Now, what is a loss? A difference between y and y hat, means the expected value of y and a y hat is called as basically a loss, or in other term you can even say as a cost. So somewhere you will be able to find out cost as a term, somewhere you will be able to find out loss as a term. Technically loss and cost is actually same, right? It's not different at all. Now there are different kind of a loss function or cost function you all will be able to find out, right? So there are like a multiple function which even I will be talking about based on the different kind of a task. So there will be a loss function and there will be a cost function. Now, or both are same actually. Now, what it does is that it will always try to find out the difference between y and a y hat. Now, once you will be having a difference between y and y hat, let's imagine, right? Then what you will do, you will try to do a backward pass. So far we were trying to perform what? A forward propagation. So in a forward direction, we were trying to move. So it's called as forward pass or forward propagation. So in a forward propagation, so we were going through whatever data is available and we were doing the very simple calculation. Now what we will do is that we will try to move through a backward propagation. So backward propagation or backward pass. In a backward propagation, what we try to do is that based on the loss, so based on the loss, we will try to change a value of this weight, this biases, this weight, this weight, this weight, this weight, this bias and this bias. This is what we do, right? This is what we do with respect to the loss all the time. So with respect to loss, we will try to do that. So here what we can do is, so we have to find out everywhere a new value of weight, right? And we have to find out everywhere a new value of our biases. This is the whole idea. That's a whole like a reality. So what will be the new value of weight? So new value of weight is basically old value minus eta. Eta is called as learning rate. I will be talking about that. And then partial order derivative of a loss with respect to what? So with respect to the weight. And here, so biases, so old biases, eta, partial order derivative of loss with respect to the biases. So this is something that we try to find out because we are already aware about the old weight and old biases. We already have a value of old weight and old biases from the neural network, right? We already have that value. So what we have to find out, that we have to find out the eta. Now, what is eta, by the way? So see, just try to observe this equation. My major objective in a backward propagation is what? My major objective in a backward propagation was to change the weight and the biases. So eventually when I'm trying to change a weight and the biases, so I'm trying to change the whole relation, right? So the way it is trying to yield my y hat. So I'm just trying to change the whole approach, whole like a relationship between. So here I'm trying to find out a new value of weight and a new value of biases based on the old weight and the old biases. So where I'm trying to use this old weight and old biases minus I'm trying to do eta, which is nothing but a learning rate. Now this is basically a constant in general. So we try to take a value of eta is equals to sometime 1, sometime maybe 0, 1 and sometime maybe 0, 0, 1. It's a standard one, but yeah, you can try to take any kind of extreme value. Now why this one is significant, and this is the hyperparameter, you can tune it basically. So why this learning rate is significant? The learning rate is significant because whenever you are trying to change your weight and biases, the old one and the new one, you should not change too fast or you should not change too slow. Right? So whatever like a numbers that you will be able to get from here, whatever number that you will be able to get from here. So you should just do the multiplication with any of these numbers, which is eventually going to control the whole changes, right? because as you can see, if you're going to complete, for example, I'll just try to give you a real life example. So when you will try to learn really fast, so actually you don't learn, you try to skip things. And when you learn very, very slow, so again, you don't learn in a proper way. So you basically start forgetting things that you have learned a long back. So you should not be a too slow, and you are not supposed to be a too fast over there, right? In terms of learning, same thing I'm trying to apply over here. So here, what is the meaning of learning? Adjusting a weight and biases. So we are not supposed to be slow, like too much slow, and we are not supposed to be too much fast. And that's the reason. So there is a eta, and eta is a hyperparameter. Hyperparameter means you can try to tune it. You can try to change this value. You can try to do the experimentation, right? Experimentation over here. The major component is basically this one, right? Basically this one. So now this is going to help you out in terms of, right? In terms of optimizing the entire weight and the biases. And this is where the concept of, this is where the philosophy of optimizer comes into a picture. That rate of change of like a L with respect to W, rate of change of L with respect to biases, right? Or maybe partial order derivative with a loss with respect to weight, and partial order derivative of a loss with respect to biases. So how we are going to change it? How we are going to change it? And this is where the philosophy of optimizer, which I'll be talking about, comes into a picture. So I believe this flow is clear. The whole idea was not to explain you the calculation. The whole idea was to explain you the whole core concept behind a neural network, which I'm going to reiterate in my next lecture once again, when I'm going to consider a input data, right? A real value, a numerical value, basically I'm going to consider. And then with the numerical value, I'll try to show you the entire calculation in a forward pass as well as in a backward pass. And then by using one of the optimizer, I'm going to show you even this derivation, and then I'll change the value of weight and biases. I'm going to show you that part as well. But logically, hope we all are able to connect that what happens in a forward pass. Let me reiterate. Simple, input will go multiply with the weight, and then like a combination of this will go into the hidden layer. Hidden layer will be having some sort of a function basically, right? So input, and then that function will give me output. Again, same thing will happen, and then eventually I will be able to get some sort of a output. Once I'll get the output, so I'll try to do the comparison with the original expected one. So difference between the original expected one and the output that you have received from the neural network is called as basically loss. Now, once I will be able to get a loss, I will move into a backward propagation. Simple. I will move into what? I will move into the backward propagation. Now, in a backward propagation, what I'm going to do, right? In a backward propagation, what I'm going to do? So in a backward propagation, basically, I'm going to change all of these values. Which values? So weight and the biases. How we are going to find out the new value of weight? How we are going to find out the new value of biases? By using this equation, So new weight is equal to old weight minus eta. Eta is nothing but a learning rate which controls the changes into the previous one, right? We should not be too fast and we should not be too slow, because both is going to harm my entire learning curve. This is what happens even in a real time. Now, so when we talk about this derivation of, or I can say a partial order derivative of a loss with respect to weight, a partial order derivative of loss with respect to biases. So here the concept of optimizer comes into a picture. I'll be talking more and more about it, right? So just wait for another lecture, right? And then you will be able to understand even in a numerical way. And hope till this part calculation is clear, and whatever assumptions that I have made is clear. This slide will be available inside your dashboard, so you can go and you can try to fetch this particular slide, and then let me know about your thoughts if you have any. And with that, thank you so much everyone. Take care and see you again in my next lecture.